Hello, you absolute legends. Here we have a triol, T-R-I, triol, O-L, for a organic compound that has 3 alcohol functional groups on it. We're going to talk about the oxidation of alcohols with this complex compound here. Now, with the oxidation of alcohols, first thing you want to identify is whether you're concerned here with a primary, a secondary, or a tertiary alcohol. And this molecule has one of each. And here's a model kit trying to show that as well that I recommend you build with your model kit. So let's kind of go down the list here and identify the primary, secondary, and tertiary. So here's an alcohol functional group. Looking at this carbon here, this carbon is bound to 2 other carbons. So it is a secondary alcohol classification. This alcohol group here is bound to 1, 2, 3 other carbons. So it is a tertiary. We put a little 1, 2, or 3 with a little degree symbol to kind of show that nomenclature. And this carbon here, this alcohol functional group is bound to this carbon, and this carbon is bound to 1 other carbon. So it's a primary. That's kind of an idea of where I'm looking and where my eyes are gazing next, and then I'm counting carbons around this right here. And like I said, this model kit is trying to show the primary bound to 1 other carbon. This alcohol group here is a tertiary because this carbon is bound to 3 other ones. And this is our secondary, bound to 2 other carbons here. Now, when this thing goes under oxidation, we would symbolize it with a letter O in square brackets for oxidation. Now, in specific oxidation reagents like PCC or potassium chromate, I'm not going to discuss the specifics of those right there, just trying to predict the products. So in trying to predict the products of any kind of reaction, I recommend getting started by just drawing what you started with. So that way all the carbons make their way to the other side of the page. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there's an OH there. And then on this terminal right here, there's another. And right here, there was a methyl, a CH3, with an OH coming up. And then just double checking here, I got a primary, tertiary, secondary. Yeah, so I think I've drawn this molecule identically. So now oxidation reactions create carbon-oxygen bonds, and oxidation reactions are not going to break carbon-carbon bonds. So let's make a carbon-oxygen bond at that spot right there. We're not going to break any carbon-carbon bonds. And oxidation reactions are also going to end up with oxygens being bonded twice. So this oxygen here is now bonded 3 times. So if something had to give, that hydrogen is lost, forming a ketone functional group. So again, a carbon-oxygen bond was made, an oxygen-hydrogen bond is lost, and if you look carefully, also a carbon-hydrogen bond was lost. Now over here with this tertiary alcohol, there is going to be no reaction with this tertiary alcohol because oxidation of this tertiary alcohol would make a carbon-oxygen bond, and then this carbon would be bonded 5 times, and carbon-carbon bonds, they are too strong. They are not going to break. So this is going to stay just how it is. Nothing's going to change here. This primary alcohol is going to form an aldehyde. A carbon-oxygen bond is going to be made. An oxygen-hydrogen and also a carbon-hydrogen is going to be broken. And here we have our aldehyde functional group, terminal carbonyl. Hope this helps. Thank you.